Okay, hello students. Here I'm making a video on. Last time I think I did for sine inverse. I did also for cosine inverse, and also I did for arc tan inverse. It means arc tan function, that is tan inverse function. So today I'm trying to show how did cosecant. So my goal is what is the function? Let's call it hx is cosecant inverse of x. So what does that mean? So my goal is to understand this inverse trigonometric function, uh, inverse cosecant function. Now what I did is, before we dive down this to few things, is I want you to remember that pi by 6, these are the ones it's better to know that pi by 6 is 30 degrees, but I'm using only in radians, which is pi by 6 is almost like 0.5. And you can see because it is 0.52, by plugging in pi is 3.14. 60 is pi by 3, you work it out, I approximate it as 1. So this pi by 3 is little more than 1. Pi by 2 is 1.57 with rounded to 1.6. Root 3 by 2 is 0.86, which is rounded to 0.9. And 2 by root 3. Now the reason 2 by 3 is because we know sine 60. So sine pi by 3 is root 3 by 2. So that's for sine. But cosecant is reciprocal of sine. So cosecant of pi by 3 is 2 over root 3, which you multiply root 3 get this, you work it out, you get 1.15, which is almost like 1.2. Now I'm going to keep this aside here. So first, before we do this, so I have a graph of cosecant. This is in general, the graph. So the domain of cosecant x is all real numbers except multiple of pi. So that we have seen why it is. So at pi, 0, pi, 2 pi, 3 pi. So cosecant is undefined. Now the point is, you see this graph is takes the same shape. Above, the range is above 1 and below -1. So that means, and then you can see this is a many one function. So because if you draw a horizontal line, then you can see these two, you can see those 2 points, they have the same y coordinate. So the goal is how to restrict the domain of the cosecant function. So what I did was, if you look at this on the left side, I started with from minus pi by 2. So this is just to make it a little easy. I'll start with the negative pi by 2, which is 90 degrees. And then I started with minus pi by 3, minus pi by 6, 0. And because 0 cosecant is undefined, and you can clearly see that it is undefined here. Then I started with pi by 6, pi by 3, pi by 2, 2 pi by 3, 5 pi by 6. And on the unit circle, you can clearly see this is basically, if it's pi by 6, every time 30 degrees I added it to it. So this is pi by 6, 2 pi by 6, 3 pi by 6, which is pi by 2. This is 4 pi by 6, which is 2 pi by 3, and then 5 pi by 6, and then 0 undefined. So the values of this, the cosecant of minus pi by 2. What is cosecant of minus pi by 2? Right here it is, cosecant is reciprocal of sine, which is, I wrote in the degrees, it is 1 over sine minus 90, and we know sine minus 90 is -1, and that's why we have this -1. Cosecant of minus pi by 3 is 1 over sine of pi by 3 is 60, so I put a minus 60 here, and sine 60 is root 3 by 2, and because it is minus, you get minus root 3 by 2, you do the reciprocal and you get minus 2 by root 3, and from that chart, so from this 2 pi by 3 is 1.2, and that's why I took minus 1.2 right there. Then 0 is undefined, and cosecant of pi by 6 is 2. That's because if you take the reciprocal, it is sine of 30 degrees, which is half, and keep change flip gives you that too. Cosecant of pi by 3 is the same thing, this one and this one, except that it has a positive number. And this is what I did. I tried to build up the table. For the first one, this is cosecant. So y is cosecant x. Now the problem is I want to swap this. Now when you swap this, the blue number, the output is right here, and the red, which is input, is the output on the other side. But the problem with this is I want to have now, because I swap this, so this input output is output input, so this xy, this has to be changed to x equal cosecant of y. And this is where the definition of inverse cosecant function comes, where we can write this y is, now this y is now we define as cosecant inverse of x. So that's how the reasoning why I write like this is because y is, so if I write just an example, it is same thing as writing like this part. Sometimes better take some example, and if I say, so if I write y is x squared, okay, and then I swap this becomes x is y squared, and that's how we write y is square root of x. So this is something new now, which is the inverse. Square root is the inverse of the square. Same thing if y is, let's say, 2 raised to x. And if I swap the table, you can make a table out of it, and if you swap this x is 2 raised to y. But then in order to write the inverse function, we need to have y equals. So now how do I write this? This is y is, then come the logarithm. So we write logarithms, the base 2 of x. So this is the inverse function. You see. Square root of x is the inverse function. And likewise, you can say that this was x equals cosecant y, so I can write like that. So that's this relation. This is a relation. Now I call this there's a xy, so this is a relation, but is it a function? But if the way it looks like, you can clearly see this 1.2, 1.2. This 1.2 is pi by 3, and this 1.2 is 2 pi by. So this is going to be one many. And you can't have one many relation. If you have you can have a one many relation, but you can't say this is a function. So it fails. So what is the only ultimate, the only way we can make this a function is, so we'll try to cut off. So we'll take this off. So we'll strike off this part, the bottom part. So we'll take it off so that this becomes 1, 1. So I cut this off, this is gone. And you get only this much, because each of the x's here has only one output. So there's no output is repeated. For 2 inputs, you don't have the same output. And then when you swap this, wow, this is going to be now it's going to be this inverse relation. Now I call this as inverse relation is a function. So now we have a cosecant inverse. Now let's graph this. Okay, take this off. And now we need to graph. So let me first graph the first part. Let me take this here. Just in case we need this. Okay. So first of all, I'm going to graph the cosecant for the restricted domain. Now, what is the domain? This one, the restricted domain is. So this one, the restricted domain is from minus pi by 2, kx, to less than pi by 2. The only thing is you cannot have x cannot be 0. That's the one thing we have to be very careful there, because it's undefined. And the range is, you can see, it goes lowest, it goes to the -1, and then it goes to infinity. So this is like from negative infinity, which we have already seen. In addition to this, and then 1 to plus infinity. So what this does is it reverses the restricted domain comes right here. So that becomes -1. This becomes -1 to infinity, the union 1 to infinity. So this one is included. and the domain here is, and I start here. So this range becomes the domain here, that's like minus infinity till minus 1, and union in addition to from 1 to plus infinity. And you can see the graph also. So the graph here also, if you see this graph, of the cosecant function, it is below minus 1 and above plus 1. And that's why when you swap this becomes the domain, and the range becomes from minus pi by 2 less than y less than pi by 2. Okay. So let's see if we get confused with this. Let's graph it now. The first one I'm going to use okay. So let's start with this one, minus pi. So where is minus pi by 2, 1? So I will take mostly let's do this one first, because to make it nice and clear. Before that, let me use, because the way I have done this, pi by 6, so I want to draw y equals x. So the question is, why do I draw y equals x? Because when you have an inverse function, the graph should be reflected over the so this is y equals x. So this is y equals. So when you graph it, you can clearly see the inverse trigonometric function cosecant. This one, it has to be reflected over this line, and you get back your original cosecant graph. So first, I'm going to graph this one, and I'm taking only this part. So if you see this, in this example, the 1, if I start with, let me graph this first. Minus 1 is minus pi by 2. So where is minus 1 here? So this minus 1 is right here. So this is minus. Okay. So minus 1 is minus pi by 2. Now, what's happening? Let me see what I did. Both the x-axis and the y-axis, I try to take multiple of pi by 6, so pi by 6, pi by 3, 2 pi by 6, 3 pi by 6, 4 pi by 6, and so on. But then I also wanted to know where is exactly is 1, okay? Because that's where the cosecant inverse of 1 is pi by 2, because cosecant of pi by 2 is 1. So that's why I try to place, where is this 1? So I picked 1 is just below pi by 3, because pi by 3 is like 1.04, and then 1.2, this is like 1.2 is because of the, this, here I wrote it, 1.2, minus 1.2, which is this one. So I try to use the same thing, which is 2 over root 3. So I'm going to do the positive part first. Let's graph only this and not that. So I'm going to pick this one first, okay? So begin with 1 is pi by 2, so 1 is right here. So if this is 1, this is 2 here, because you need 2 also. Because 2 pi by 3, this is like 1.08, 2.08, which is almost like 2.1. So 2 is little below that. And how do we know this is because of this pi by 3, this pi by 3 is 1.04, so double of that will be 2.08. So 2 will be little to the left side. A lot of confusion. I did not want to do this because I just really wanted to see how it works, you know. This is my first time I'm showing this exactly with each real numbers type of thing. So I'm gonna, okay, this is 1 is pi by 2. So 1 is pi by 2. So this is 1, pi by 2 is right here. So let me use the color. Okay. So this one is going to be pi by. So there you go. This is one. Pi by 2 is right here, so I'm going to mark it right here. Okay. So this is 1 is pi by 2. So this one is pi by 2. So let me see if I can write 1 is the pi by 2. This is pi by 2. Okay, so that's the first one. And that's 1.2 is pi by 3. Where is 1.2? This 1.2 is pi by 3. So this is pi by the black color. So 1.2, this one is pi by 3. The pi by 3 is right here. So I'm just approximately somewhere here. So that's 1.2 is pi by, this is pi by 3. Okay, correct. And then you have 2 is pi by 6. So where is 2? 2 is right here. Pi by 6 is right here. So that's an easy one. So 2 is this one. So this is 2 is pi by 6. Okay. Now let's graph this also. Now, what does this mean is we will see the 0. This when you swap this, it means the y-axis. This y-axis is going to be the horizontal asymptote. Let's first check on the other side also. Minus 2 is minus pi by 6. So if this is minus pi by 6, minus 6 is minus 2 is right here. So we're gonna use this. So minus 2, and this is right here. So that's minus 2 is minus pi by 6. Okay. Then minus 1.2. So this is minus 1.2, exactly like how we have 1.2 to the right side of pi by 3, and to the left of minus pi by 3 will be minus 1.2. So that will be minus pi by 6. So where is minus pi by 6? Right here. And this will go somewhere here. Sorry, it is minus pi by 3, right? So minus pi by 3 is right, this black color one. So this will be here somewhere here. So this is minus 1.2 is minus pi by 3. So that is taken. So each one I'm taking 1, 2, we took this, and now finally it is minus 1 is pi by 2. So where is minus 1? This is minus 1. So exactly at minus 1. And it is minus pi by 2. So there it is, this is. So that's negative 1 is negative pi by 2. Okay, and now let's graph it. So I'm gonna use, I did use the black color. Let me use the green color for this to graph this. So this graph will look like this. Watch this. This is the stars and go this way, and then this goes as the value become larger and larger. This almost comes very closer to the x-axis, and the same thing. This one is okay, and then this is a lot of work. I didn't mean to show this, but I was just started liking this. Let's see if this I have to extend here. The x-axis. This will go all the way like this. Oh, this is the cosecant inverse of x graph. Now I also wanted to show you where is the where is the original restricted domain cosecant function? So let's take that. And for this, I'm gonna, let me try something different. Okay. So let's see what is this one. We'll start with pi by 6 is 2. Where is pi by 6 is 2? So this is pi by 2. Pi by 6 is 2. So this is pi by 6 is right here. Okay, watch this. So this is 2. This is here. Pi by 6 is 2. Here. This is 2. This is 2. This is, so this is pi by 6 is 2. I want you to think that, look at this. This point is the original one, but this is 2 pi by 6, and that is pi by 6 too. So they are just, they are like reflected over the line y equals x. Let's first plug in the values. The next one is, I did the pi by 6. Okay, this one, pi by 6 is done. Now, pi by 3 is 1.2. Where is pi by 3? Pi by 3 is right here. Pi by 3 is 1. Now, 1.2 is over here. Look at this. Pi by 3 is 1.2. So, this is 1.2. That right here. So, this is pi by 3. And it is at 1.2. Huh. Okay, and then the last one is pi by 6 is 2 is that, pi by 3 is 1.2, and pi by 2 is 1. So where is pi by 2? Pi by 2 is here, and 1 will be, so the 1 will be, if you see this 1 here, now here is clashing, so what I'm going to take this off and then write on the line, right, so 1, this is 1.2, and pi by 3, so let me take this off, so that I can have, so this is pi by 2 is right here, this is pi by 2, and pi by is 1, so where is 1? That's the 1, right? So I go across somewhere here, somewhere here, so this is the 1. So this is pi by 2, and it is at 1. Now, and then now we have to graph, and we can do the same thing on the other side also. So here you will see the points. So you can start with, so difficult. Anyway, this I'll do the reflection points somewhere here. So if you see these two dots are reflected, so this dot will be this side. Okay, and this dot this dot will come here. Pi by 2. Did I make some mistake? Yeah. So I wanted to make sure I'm doing it correct here. Minus pi by 6 will be minus 2. So minus 2 will be this one. I don't have, I'm not shown this side. There's no enough room here. So what I'm saying is at minus pi by 6 is this one I can't show, but minus pi by 2 is minus 1. I think that's the one we can do. So minus pi by 2 is minus 1 here. This is minus pi by 2. So minus pi by 2 right here is minus. So that's the main point here. And that's the point. And let's see what's happening. I'll try to show on the other side. This side, the graph is, use orange color graph. Okay, so this is the graph. Let me use a blue color graph. Okay, so this graph starts from here. Okay. Then this is the point, X point. Okay. And then goes through Okay, anyway, so this goes through this point. And then it goes through this point and then goes up this way. You can clearly see it's not that be good. This is not, this goes maybe this way, this goes this way. Like this. So, and the same thing is here, I can't show this, this is minus pi by 2. So it goes like this. And goes down and down and down. So the main thing is to be take away is look at this. The green one is the cosecant inverse function, and you see this point reflects over this point. So this was pi by 3 was 1.2. So this point was pi by 3 is 1.2, but now it is 1. So they reflect. So this reflects, so this two reflect, then this 2 point reflect over the y equals x. So if this is the pi by 2 1, but the green color, the inverse is 1 pi by 2, and then also you can see this point reflects here. So if this is pi by 6, there you go. So this is my goal, to just to show how to graph cosecant inverse of x. Most of the time, you just remember that we just do. How do we do? Is okay. We know that the inverse trigonometric function cosecant is, we say minus 1 and 1. Okay, and then we say okay, it doesn't define at this point. So we say okay, we put pi by 2. And minus pi by 2, and then straight away we graph. Remember that, okay, 1 is pi by 2, because cosecant of pi by 2 is 1, so you go cosecant inverse of 1 is, and then go this way. And the same thing you do other way is this one, minus 1, and then this is all we remember. So, but the actual is, that's how it is, how beautiful this is to see that cosecant inverse function graph. You can see clearly it begins at 1, so that's the here on the right side 1 and goes to infinity. So that's why we say okay, it starts from 1 this side and goes all the way till plus infinity. But this is union on this side. It starts from the left side and then it goes until 1. So this part this is that 1. And that's why we put close bracket to show that that's the domain. This is the domain of this. But the range is from minus pi up. So the graph of the cosecant inverse is from minus pi by 2 till plus pi by 2. So the range is minus. So it goes down. So it goes down until here. That's the last part. You cannot go beyond that. This is the one. So it is minus pi by 2, less than equal values, and goes until pi by 2, this one, pi by 2. So that's like the y, pi by 2. But y cannot be 0, and you can see that you can't have y equals to 0, because here x at cosecant of 0 it was undefined, and that's why this graph looks this way. Hope this helps. Okay, guys, just watch this 2 times maybe. I know it is so much complication I did, but just wanted to make you guys to do manually. Okay, the Desmos digitally it is so easy. You can just plug it in those values and you can get the answer. So now in the next 5 minutes, I'll show you how to see this digitally, the graph. Okay, so now I'm going to put my laptop here to show. Okay, here it is. Okay, here. I think I have to lift it a little bit here. Oh, I'll bring it down this time. Okay, that will help. Okay, so here it is. Okay, now what I trying to show you here is here is the one that I put. I try to show the cosecant function, that is, and remember the domain of cosecant is everything, all real numbers. So what I did was I took some of this, the same thing. I started with minus pi on this one, and then went on going until pi here. So if you see all this, let me take this off. Okay, so in the beginning, so we have this, and I'm trying to restrict. So you saw that it is better we start from minus pi by 2. So I'm taking this off, so we don't want this. Okay, we don't want this also, and we don't want this also. So I'm restricting from minus pi by 2. There you go. This is minus pi by this is actually the 2 root 3 over 3. Then at 0 it is undefined, and I took pi by 6, and then until pi by 2. So this I'm taking off because that doesn't help. Okay, and we don't want this also. We'll take this off until pi by 2. So this is, and you can see clearly you go up here and write, okay, this should be minus pi by 2, minus pi by 2, and I have to put equal sign here also, and then equals pi by 2. And you can clearly see this was the graph restricted domain, the one that I showed all this to be seen. So that's minus pi by 2, 1. This is my minus pi by 3, that is minus 1.2. And then minus pi by 6 is minus 2. Then again, increases 0, pi by 6 is 2, and same thing. What I did next was, I wanted to see the inverse, right? So take this off, and I wanted to put this in the beginning. There is a vertical asymptote because the cosecant is undefined for 0 degrees. So that's why I put that dotted green line. Okay. Let me make it a little bigger. Okay, here it is. Okay, pi by 6. I want to see pi by 6 here. Okay, there it is, pi by 6. Okay, now I try to write gx is cosecant inverse of x. So this is cosecant inverse of x, and this time this input output which is right here, I am swapping it. Here it is. It's the same thing. Minus 2 is this minus pi by 6. That's minus pi by 6. Okay, that's minus pi by 3. That's minus pi by 2. That plus pi by 2. And that is pi by 3. 2 pi by 3. And so on. So, and I'm putting it on. If I put it on, you can clearly see, and I want to see the graph also. Watch this. So here is the point inverse. Whatever I did there, if you see, whatever we showed right there, see this thing? It's the same thing here digitally. So easy to know. Okay, so, and that y equals x is, if I put that dotted line, and you can clearly see this point. Let's take one point here, starting with pi by 2. So inverse function is cosecant inverse of 1 is pi by 2, because cosecant of pi by 2, 2 is, I made a slight mistake here. That's not the one. So if this is 1 is pi by 2, this is pi by 2 1. Because cosecant of pi by 2 is 1. So cosecant inverse of 1 is pi by 2. So they reflect each other. See this point? And also you see this point is pi by 6 2, but then this one is 2 pi by 6. So this this point is the reflection of this point. And then you can see this little one here, it is pi by 3 is 1.5, but this one is 1.15 is pi by 3. And that's all I try to show on the manually. Okay, so this is just wanted to show how to do digitally also. So cosecant inverse is, this is the graph of, so this, the blue color is the graph of cosecant inverse function, and it is thus just the opposite of a reflection of the restricted graph or restricted domain of cosecant of x. So that's all I wanted to share, and hope if you go this way, it looks so beautiful. Look at this. So thank you for watching. Actually, just for intuitive way of learning to understand how things work. So the next one I'm gonna try is secant inverse. Stay tuned.